Hello, ninth graders. Yesterday, we filled out this page of notes, and I warned you in class yesterday that step number 1 right here, you wouldn't really need to do yet. We didn't have to do that on any of the examples down here. On today's examples, we are going to need to sometimes isolate the absolute value expression. And then we will move into where we started yesterday with this keep it, switch method. Absolute values turn into two inequalities. So we're going to practice and refresh how to do that. And then of course, solve and graph and write the interval notation the way we always know how. Really, the only stuff that's new here are steps 1 and 2 with the absolute value. So with that in mind, flip over to page 20 and let's go through these examples. Okay. First thing I always do, again, as we talked about yesterday, I look at this symbol here and I say to myself, this is an or statement. Any greater than statement is an or statement. And that helps me because I already know how or statements are supposed to work. I already know that the graph's supposed to go in opposite directions. I know how interval notation looks. I know I have to solve them separately and write them separately. So getting this processed in my head right away helps me before I even start. Now that I've got that processed, now I'm ready to break this into two inequalities. The first one is always going to be the original inequality, just dropping off the symbols. Which symbols? The absolute value symbols. The second one comes from keep it. And what is the it that we keep? Anything in the absolute value. The stuff inside the absolute value is going to stay. Sometimes I say this in my own brain and it's goofy, but it helps me remember. Whatever is in the absolute value absolutely must stay. That helps you. So there's my keep, switch. Now I have broken it into compound inequalities, and compound inequalities are a thing I already know how to do. So I'm going to solve this half. By the way, remember, if you haven't watched a math video in a while, if I'm ever moving too fast or you didn't have time to write stuff down, you can always pause it. That's the nice thing about video McGowan versus real life McGowan. You can pause me and write it down. There's one half. You guys can also let me know when I'm back tomorrow if I made any mistakes, because we all know I do that sometimes. Divide by 2. Here's the other half. If I did my work correctly, which I think I did, that means I didn't need to reverse any symbols. I didn't divide by any negatives. This is my inequality solution. Now I can come over here and do my graph solution, close circle at -1. Close circle at -4. These are kind of written backwards over here. So when I look at this, I'm like, oh yeah, less than to the left, greater than to the right. And it does look like the or statement is supposed to look. Phew. Now my interval notation, -infinity up to -4, or I never have enough room in that spot for my interval notation, but there it is. Once again, new stuff today is just breaking the absolute value into a compound inequality. Okay, look at number 6. Uh-oh. This is what we mean by isolate the absolute value expression. There is some stuff over here that it's on the same side as the absolute value, but it's not in the absolute value. That's going to make things very, very weird. So before, notice it's step number 1. Notice it is before you split it into 2, before you keep it switch, you're supposed to look for this. So before I even worry about or and or anything like that, you know what I have to do? I have to get rid of that -1. And how do I do it? The same way I would in anything. If there is a -1, then I am going to add 1 to both sides. Now this says the absolute value of x plus 3 is less than 6. I am not ready to do the keep it switch until I've made it so that the only thing on the left-hand side is in the absolute value. I want everything in the absolute value. Now it's there. Now I'm ready. Now I can look at this and I can say, ooh, this is an and statement. And I hinted at this yesterday. But because it drives me crazy with and statements to split it apart and then bring it back together, here's how we're going to deal with and statements. This is the keep it part. That's exactly what's there. I just dropped off the absolute value. And here is the switch. And if you're like, Miss McGowan, you didn't actually switch anything. I really did if you read it backwards, which is what an and statement does anyway. So I basically just moved the stuff inside the absolute value to the middle, and I put positive distance from 0, negative distance from 0 on each side. And this is going to be so much nicer for me to solve because now I don't have to split it apart in 2. I can just go -3 everywhere and take care of it all at once. And it's already back together in an and statement, which makes it a lot more clear for me on how to graph. Open circle at -9, open circle at 3, and statement, connect them, interval notation, done. Okay, what about number 7? I know what you guys want to do because you're so trained to do this. You really want to multiply everything by 3. But that's a thing that we do if these are parentheses, and they are not parentheses. So this is an entirely different meaning. I can't distribute through an absolute value when this stuff is in the absolute value and this isn't. So guess what I have to do? I have to isolate the absolute value first. I'm not going to distribute it. That would be very weird because these aren't parentheses and that's not what that means. So here's what I'm doing. Ready? Divide both sides right now by 3. Why? Because there was a thing outside the absolute value and I had to get rid of that thing. I can't move forward until I get rid of stuff that's not in the absolute value. That cancels to 1. And that's all that happens. Now here, absolute value of 2x plus 8 is greater than or equal to 10. Now I am ready to say, oh, this is an and statement. What? No, this is an or statement. Greater than means or, right? So I am going to copy the original one. I'm going to write the word or, and now I'm going to keep it, switch. And this is going to get squishy because this box really does not have enough room for me. But I'm going to go -8, -8. This is going to say 2x is greater than or equal to 2. And then I'm going to divide by 2, divide by 2. And I'm going to write my answer up over here. I'm going to bring this over here so I have space to write my stuff. This one turns into x is greater than 1 or, all right, let's check the other one. -8 -8, 2x is less than or equal to -18. Divide by 2, divide by 2. And this one, x is less than or equal to -9. There is my compound inequality. X is greater than 1, looks like this. X is less than or equal to -9, looks like that. Okay, good. It looks like an or statement like it's supposed to. Good sign. My interval notation then, I'm going to start with this one down here. From -infinity up to -9 with a bracket. Or 1, oh no, parenthesis. That's an open circle, Miss McGowan. Parenthesis from 1 to infinity. Make sure you write a parenthesis, not a bracket, like I accidentally did. Okay, just 3 more. Here we go. Check this out. Isolate the absolute value first. To try and not run out of room, I'm going to do this instead. Ready? I'm going to go. They are dividing by -2. So check this out. This is so tricky. I have to multiply by -2, and then I have to multiply this side by -2. But guess what? This is still an inequality, and I just multiplied both sides by a negative. So before I'm even ready to deal with the absolute value stuff, here's what I have. You watching? Write this down. I have absolute value of 4x minus 8. I have to reverse this symbol now, which changes everything. And why am I reversing that symbol? -6 times -2 is 12, because I multiplied both sides by a negative, and that still applies even with absolute values. Anytime you multiply or divide both sides by a negative, you reverse the symbol. Now I should not be looking at this original one. That is why it says isolate the absolute value before you create two cases. So now that I have isolated the absolute value, now I can look at this and I say, oh, it's greater than now. So this is another or. All right, so here I go. I either have 4x minus 8 is greater than or equal to 12, or I keep it, switch, switch. And now it's an or statement, so all I can do is solve these separately. Here I go. Add 8 to both sides. 4x is greater than or equal to 20. Divide by 4, divide by 4. You don't have to do, I just got so into adding 8 that I did it everywhere. X is greater than or equal to 5, or this half, negative 12 plus 8 is negative 4, or X is less than or equal to negative 1. None of that required me to reverse symbols. So there's my inequality. Now I'm going to do close circle at 5, greater than. Close circle at negative 1, less than. Phew, looks like an or statement like it's supposed to. Negative infinity up to negative 1 with a bracket, or bracket 5 to infinity. Why didn't you guys stop me up here? Do you know what I just realized? And I don't know, maybe you realized it and looked at it. You know why I was so anxious to write a bracket here is because absolute values can't end up with two different. That doesn't make any sense when they came from the same starting point. So for some reason right here, I just dropped off the equal to part. I don't know. So this really is a closed circle, and my brain obviously knew what it was doing from the start. That's what we'll say was happening. Okay, so these are both brackets. Absolute values always have to be the same because they came from the same starting point. So either they both have a line on them or they both don't. They're both closed circles or they're both open circles. We are going to do one more. It's kind of a big one. And then we're all going to write skip on this last one. So then after I finish number 9 and your video's all done and these are done, you can also write skip over here. After we do that last one, you guys are going to submit a photo of page 20, and I can see skip written on these ones. That's fine. And then you're going to go get the worksheet from the substitute. But first, number 9. Okay, isolating the absolute value here is going to require me to do this first. It's kind of like a two-step equation. If this just said 10x minus 3, then I would get rid of the 3 first and then get rid of the 10. That's what I'm doing here. There's just a weird absolute value in it. I'm going to come right over here. Again, these boxes are just not big enough for all the math I want to write. This says greater than 47 plus 3 is 50. Now I divide this 10 off. Okay. And now this says absolute value of x minus 4 is greater than 5. I added 3 to both sides and then I divided both sides by a positive. So nothing I've done so far requires me to reverse the symbol. However, now I see this. I know this is an or because greater than is or. So I'm going to say x minus 4 is greater than 5, or keep it, switch, switch. There's my options. Now, all I have to do to solve these ones is add 4 to both sides. So x is greater than 9, or add 4 to both sides. X is less than negative 1. These are both open circles. It's okay that you're missing a number on here. Let's go to 9. Maybe that wasn't supposed to happen and you guys will tell me that I did it wrong. Totally possible. This is 9 here. So we're going to do open circle to the right, open circle on negative 1 to the left, negative infinity to 9, or negative 1. What, Miss McGowan? I'll just start with this one, right? From negative infinity to negative 1, or 9 to infinity. Okay, right. Skip on those last two, take a picture and submit a photo of your notes. So I know you're doing what you're supposed to be doing, and then go ask the sub for the worksheet and start your Canvas quiz. I will see you tomorrow.